There is a bird at your feeder right now that is preparing to disappear. Not suddenly, not overnight. The preparation has already been underway for weeks, and you have been watching it happen without knowing what you were seeing. You noticed it eating more than usual. More time at the feeder, less time sitting still. A kind of urgency that did not match the calm bird you had been watching all summer. You probably thought nothing of it. Maybe the weather was changing. Maybe the seeds were particularly good that week. But that was not what you were watching. What you were watching was the opening stages of a biological transformation so extreme that if it were happening inside a human body, it would constitute a medical emergency. The bird at your feeder is not just eating. It is being rebuilt from the inside out in preparation for something that will happen in the dark above your house on a night not long from now. And the scale of what that small animal is about to do on a body it has been quietly engineering for weeks while you refilled the feeder and went about your morning is something most people who watch birds their entire lives never fully grasp. Welcome back to Backyard Bird Mind. Subscribe before you leave because what you are about to learn happens in your yard every single fall and spring, completely invisible, and it will change the way you look at every bird that visits your feeder from now on. Today we are going into the biology of what a migratory bird does to itself before it leaves. What is actually happening inside that animal in the weeks before it disappears from your yard, and what the science reveals about the journey it is preparing for. Stay until the end because the last thing we cover is the one that most people never connect to their own yard, and once you understand it, the feeder outside your window will never mean quite the same thing again. The scientific term for what you are watching at the feeder is hyperphagia, controlled, deliberate overeating, triggered not by hunger but by hormones, initiated by the bird's brain in response to changes in the length of the day. As the days shift across the season, photoreceptors in the bird's brain detect the change and begin releasing a cascade of signals that fundamentally alter the animal's relationship with food. Under normal conditions, a bird regulates its intake carefully. It eats enough to maintain weight and no more. Fat is expensive to carry and makes flight harder. But during hyperphagia, that regulation is suspended. The bird eats past the point where it would normally stop. It eats continuously. It stores fat at a rate that in any other context would be pathological. A Blackpoll warbler weighs roughly 12 grams in normal conditions. In the weeks before migration, it will reach 20 grams or more, nearly double. Most of that added mass is pure fat. Fat that will be burned as fuel during a flight of up to 2,500 kilometers over open ocean, from the northeastern coast of North America to South America, with no opportunity to land, no food, no rest, for 3 to 4 days of continuous flight. The urgency you noticed at the feeder was not random, it was engineering. Every seed that bird took was being converted, with a biochemical efficiency we are still learning to fully measure, into the fuel that will carry it over water and darkness, and distance that would kill most animals before they covered a fraction of it. But the fat is only part of what is happening. This is where the biology becomes something that stops researchers mid-sentence when they explain it to people who have not heard it before. In the same weeks that the bird is gaining weight at your feeder, it is also losing organ mass, deliberately, selectively, as part of the preparation. The digestive system, the stomach, the intestines, the organs that process all the food it has been consuming, begins to reduce in size. In some species, the digestive organs shrink by 25 to 50% of their pre-migration mass. In birds that will cross an ocean without stopping, the reduction is even more dramatic. The reasoning is straightforward once you understand the constraint. During a non-stop crossing, there is nothing to eat. The digestive system has no function. It is weight with no return. And weight over a 3-day ocean flight is the difference between arriving and not arriving. So the bird dismantles it. At the same time, the flight muscles, the pectoral muscles that drive the wings, increase in size. The heart enlarges slightly to support sustained high-output effort. The body removes what it will not need and builds what it will. It does this on a schedule, in a sequence, regulated by the same hormonal cascade that started the overeating. The bird sitting at your feeder looking somehow lighter, somehow more alert than it did a month ago, has already started taking itself apart. The transformation is well underway before it ever leaves the ground. Research published in the Journal of Experimental Biology followed red knots, long-distance shorebirds that fly from the Arctic to the southern tip of South America, through the entire preparation cycle. Before departure, their digestive organs shrank dramatically. After arrival and the resumption of feeding at the other end, those same organs regrew within days. The bird does this twice a year. The body disassembles and rebuilds itself on a seasonal schedule, with a precision that has no parallel anywhere else in vertebrate biology. When you look at a bird at your feeder in September and notice something slightly different about it, something you cannot quite name, you are not imagining it. The animal in front of you is not the same animal that was there in July. It has been changed, physically and profoundly, by a process that has been running in the background of every ordinary morning you spent watching it eat. The question of how it knows where to go once it leaves is the part that most people think they understand, and almost no one actually does. The common version goes like this. Birds follow coastlines, rivers, landmarks. They inherit a general sense of direction. They learn the route by following older birds. This is true for some species in some contexts, and it is a fraction of the complete picture. The complete picture includes something that was not confirmed by science until the 1960s and is still not fully understood today. Birds navigate using the Earth's magnetic field, not as a vague general sensation, not as a rough directional pull, as a precise, real-time navigational instrument with an accuracy that researchers are still working to explain. The mechanism involves specialized proteins called cryptochromes, located in the bird's eye. These proteins react to magnetic field lines through a process that operates at the quantum level, at the scale of individual electrons, and the signal they produce travels directly into the bird's visual system. The current leading hypothesis is that the bird does not merely sense the magnetic field, it sees it, as a visual overlay on its normal vision, a compass that is part of sight itself, invisible to every other creature in the same sky. A European robin, flying south through the dark over an unfamiliar landscape, is not searching for landmarks. It is reading a map written in magnetic field lines that you cannot perceive, have never perceived, and have no sensory architecture to perceive. The Blackpoll warbler leaving Cape Cod in October, out over the Atlantic, over water with no land in any direction, is not estimating. It is locked onto a navigation system that does not require stars, does not require landmarks, does not degrade in clouds or fog or complete darkness. It knows where it is going, with a precision that required decades of careful science just to detect and document. Stars matter too. Nocturnal migrants calibrate their star compass during a critical window shortly after hatching, before they have ever flown more than a few hundred feet from where they were born. On the first clear nights of their lives, newly fledged birds stare up at the rotating night sky and memorize its structure around the celestial pole. They are building the navigational system they will need months later, before they have any reason to need it, before they have any experience of migration at all. The bird that hatched in your yard last summer, the one you watched go from a bare nest to a first uncertain flight across the lawn, spent its first nights quietly constructing a map of the sky. It was doing this while you were asleep. It will use what it learned on those first nights to navigate a continent in darkness before it is a year old. The timing of when the transformation begins, when the eating intensifies and the organs start to shift and the restlessness builds, is controlled by light, by the length of the day measured with an accuracy that makes any human instrument seem crude by comparison. Photoreceptors in the bird's brain, not just in its eyes, but in the brain tissue itself, responding to light that passes through the skull, track the ratio of light to dark across the 24-hour cycle. As that ratio crosses a threshold specific to each species, a hormonal cascade begins. The eating starts. The organs start shifting, and a behavioral state that ornithologists call Zugunruhe begins to take over. Zugunruhe is the restlessness of a bird that is ready to go. Captive migratory birds held in laboratory conditions with no access to the outdoors, no weather cues, no other birds to follow, still develop Zugunruhe on schedule. They become agitated and active at night during the period when they would normally be in flight. They orient their restlessness in the direction of their migratory route. A captive blackcap warbler from a population that migrates southwest to Africa will move toward the southwest wall of its enclosure every night during migration season. It has never migrated. It has no experience of the route. It has been in a cage its entire life. And still, when the light crosses the threshold, when the hormones shift, its body knows which direction to point. What you are watching at the feeder in those final, intense weeks is not a choice the way we think of choices. It is a cascade, built over millions of years of evolution and activated by nothing more than the angle of light, running its sequence in the body of a bird that weighs less than a handful of coins. The birds that attempt non-stop ocean crossings have no margin. The ruby-throated hummingbird that will arrive at your feeder in May crossed the Gulf of Mexico to get there. 800 to 900 kilometers of open water with no land in any direction, no food, no rest, no possibility of stopping if something goes wrong. The crossing takes approximately 18 to 22 hours of continuous flight. The bird weighs 3 to 4 grams at departure. Researchers tracking hummingbirds along the Gulf Coast before the crossing have documented individual birds still feeding at the last available land, still adding final reserves, watching the wind, waiting for conditions to shift in their favor. They wait for a tailwind. They monitor the sky. And when the variables align, they go. There is nothing tentative about it. The preparation has been running for weeks. The body has been rebuilt for exactly this. And when the moment arrives, the bird commits completely. What it burns over the Gulf is what it stored at feeders like yours. This is the part that most people never connect directly enough to their own yard. The Blackpoll warbler, at 20 grams, loaded with fat it accumulated over weeks at feeders across the northeastern United States, departing Cape Cod in October, flies east and south over the open Atlantic for 3 to 4 days without stopping, without eating, without sleeping in any conventional sense, and arrives in South America lighter by nearly half its departure weight. The fat it built up, calorie by calorie, at your feeder and feeders like it across thousands of backyards, is the fuel that makes that crossing possible. Not metaphorically, directly. The seed you put out becomes subcutaneous fat in a precise anatomical sequence. That fat becomes energy over the Atlantic in October. The chain from your feeder to the open ocean is that short and that specific. Every morning you filled it. You were part of a preparation you did not know was happening. And then it comes back. This is the thing about migration that most people who love birds feel instinctively but do not know the science of. Site fidelity. The documented, GPS-confirmed, repeatedly verified phenomenon of migratory birds returning not just to the same region, not just to the same neighborhood, but to the same yard, the same feeder, the same tree. Studies tracking individual birds with leg bands have found wood thrushes returning to specific addresses in Maryland after wintering in Honduras. The same bird, the same house, multiple years in a row. It navigated from Central America to a specific backyard with a spatial accuracy measured in meters. The bird that disappeared from your yard last fall, the one that ate with unusual intensity in the weeks before it went, Has your yard stored as a coordinate somewhere in a brain the size of a walnut? It knows the location of your feeder. It knows the cover in the dense shrubs along the fence, the water source, the specific trees where it feels safe. All of that information is being carried right now, thousands of miles away. And when the days lengthen and the hormones shift and the Zukunhua takes hold, the direction it points is not just north. It is toward a specific point. Your yard is a destination in a navigation system running inside a bird you have not seen since fall. It is coming back. The feeder is empty right now. The branches are still. The birds that were there all summer have gone or are going. And the yard has that particular quiet that comes in the weeks after they leave. But what you are looking at when you see that stillness is not absence. It is the aftermath of a transformation. The birds that ate at your feeder with such urgency in September left carrying the fuel you gave them, on bodies they rebuilt while you watched without knowing what you were seeing, navigating by a compass built into their vision that you will never perceive. Following coordinates written into their biology on the first clear nights of their lives. They are out there right now, over water or mountains or the dark interior of a continent, using what they prepared, using what you gave them. And on a morning not long from now, on a day when the light has shifted back and the trees are just starting to show color, one of them will return to exactly where you are standing. It will land on the familiar branch. It will look at the feeder, and the season will begin again. Tell me in the comments, have you ever noticed a bird eating more than usual in the weeks before it disappeared? Or come back one spring and realize the same bird had returned to the exact same spot? I want to hear about it. I read everyone. These are the stories I carry the longest. I will see you in the next one.